The proposed electrical installation with a 225 amps panel tapped to a 400 amps panel using 500 kcml feed via 4/0 conductors, where the 225 amps panel has main lugs only, does not comply with National Electrical Code Section 240.21 bone, the 10-foot tap rule. The tap rule allows for a tap to supply a single unit panel board. It does not allow for a tap to supply 2-unit panel boards as proposed in this installation. The intent of National Electrical Code Section 384.16, which requires overcurrent protection for switchboards and panel boards, cannot be circumvented by using the tap rule in this manner. The 225 amps panel must have overcurrent protection installed to properly protect the conductors and equipment connected to it. The use of subfeed lugs in the proposed installation is not appropriate because the calculated connected load exceeds the ampacity of the subfeed lugs. Subfeed lugs are typically rated for 100 amps or less, while the calculated connected load in this installation is 375 amps. The installation must be modified to provide the required overcurrent protection for the 225 amps panel. This can be achieved by installing a main breaker or fuses in the panel. Furthermore, the subfeed lugs should be replaced with a properly sized feeder breaker to handle the connected load of 375 amps. A more detailed explanation follows. National Electrical Code Section 240.21 covers the location in a circuit of overcurrent protection devices. The general requirement is that overcurrent protection must be placed at the point where conductors receive their supply. This protects the conductors from overcurrents. However, several exceptions to this rule allow conductors to be tapped from a feeder without overcurrent protection at the tap point, provided certain conditions are met. One such exception is the 10-foot tap rule found in Section 240.21 bone. This rule allows a tap not over 10 feet long to be made from a feeder without overcurrent protection at the tap point, provided that several conditions are met. Firstly, the ampacity of the tap conductors must not be less than the calculated load in the tap conductors. Secondly, the tap conductors must not be less than the rating of the overcurrent protective device at the termination of the tap conductors. Thirdly, the tap conductors must be installed in a raceway when not installed in an approved manner. Fourthly, the tap conductors must not extend beyond the equipment they supply. Fifthly, the tap must supply a single overcurrent protective device that will protect the tap conductors from overcurrent. In the proposed installation, the 4/0 conductors tapping the 500 kcml feeder are intended to supply 242 circuit panelboard sections via subfeed lugs in each panel. This does not meet the requirements of the 10-foot tap rule because the tap supplies more than one overcurrent protective device. The tap rule is intended to allow a short tap to supply a single overcurrent protective device, such as a circuit breaker or set of fuses, that protects the tap conductors from overcurrent. In this case, the tap is supplying multiple overcurrent protective devices in the two panelboard sections, which violates the intent and specific requirements of the 10-foot tap rule. National Electrical Code Section 384.16 contains requirements for overcurrent protection of panel boards. Specifically, 384.16 requires that each lighting and appliance branch circuit panel board be individually protected on the supply side by overcurrent protective devices having a rating not greater than that of the panel board. This requirement is intended to protect the panel board and its connected conductors and equipment from overcurrents. There are exceptions to this requirement. One exception is found in 384.16 exception number 1, which allows a panel board to be protected by the overcurrent protective device protecting the feeder to which the panel board is connected, provided that the panel board is not a lighting and appliance branch circuit panel board. A lighting and appliance branch circuit panel board is defined in 384.14 as a panel board in which more than 10% of its overcurrent devices, rated 30 amps or less, are used for lighting and appliance branch circuits. In the proposed installation, the 225 amps panel board has main lugs only, meaning that there is no overcurrent protection device in the supply side of the panel board. The designer is attempting to rely on the overcurrent protection device on the 400 amps feeder to protect the 225 amps panel board. However, this is not permitted because the 225 amps panel board is a lighting and appliance branch circuit panel board and therefore must have its own overcurrent protection device as required by 384.16. The lack of overcurrent protection on the supply side of the 225 amps panel board also means that the tap conductors are not protected from overcurrents, which violates the general requirement of 240.21 that conductors be protected at their point of supply. The use of subfeed lugs to connect the tap conductors to the 242 circuit panel board sections is also problematic. Subfeed lugs are typically rated for 100 amps or less. In the proposed installation, the calculated connected load for both panels is 375 amps, which exceeds the ampacity of the subfeed lugs. This means that the subfeed lugs would be overloaded, which could lead to overheating, damage, and potentially a fire hazard. The subfeed lugs are not rated for the amount of current that they would be carrying in this installation. The calculated load of 375 amps needs to be supplied by conductors and overcurrent protection that is rated for that amount. The installation must be modified to correct these deficiencies and comply with the National Electrical Code. Firstly, overcurrent protection must be provided for the 225 amps panel board. This can be achieved by installing a 225 amps main breaker in the panel board or by installing a set of fuses rated at 225 amps in a disconnect switch ahead of the panel board. This overcurrent protection device will protect the panel board and its connected conductors and equipment from overcurrents, as required by 384.16. Secondly, the subfeed lugs must be replaced with a properly sized feeder breaker to handle the calculated connected load of 375 amps. This can be achieved by installing a 400 amps feeder breaker in the 400 amps panel board and running a properly sized feeder, such as 500 kcmil copper conductors or 750 kcmil aluminum conductors, from the feeder breaker to the 225 amps panel board. This feeder breaker and feeder will provide adequate overcurrent protection and ampacity for the connected load. It is important to note that the specific requirements for conductor ampacity and overcurrent protection device sizing will depend on the specific characteristics of the installation, such as the conductor type, insulation temperature rating, and ambient temperature. The National Electrical Code contains detailed tables and calculations for determining the appropriate conductor ampacity and overcurrent protection device sizing for different applications. The relevant tables include National Electrical Code Table 310.15b16 for conductor ampacities, National Electrical Code Section 240.4 for overcurrent protection requirements, and National Electrical Code Section 310.15 for ampacity correction factors. The installation should be carefully reviewed and designed by a qualified electrical engineer or electrician to ensure that it complies with all applicable requirements of the National Electrical Code and other relevant codes and standards. This review should include a detailed load calculation to determine the actual connected load and demand factors for the installation. The conductor ampacity and overcurrent protection device sizing should be based on this load calculation. It is also important to consider the voltage drop in the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends that the voltage drop in the feeder and branch circuit conductors should not exceed 3%. The voltage drop can be calculated using the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current constant, 12.9 ohms for copper and 21.2 ohms for aluminum, I is the current in amps, D is the one-way distance in feet, and circular mils is the circular mil area of the conductor. The conductor size should be increased if necessary to keep the voltage drop within the recommended limits. The proposed installation violates the 10-foot tap rule because the tap supplies 2 panel board sections instead of 1. The installation also violates the overcurrent protection requirements for panel boards because the 225 amps panel board does not have its own overcurrent protection device. Finally, the subfeed lugs are undersized for the calculated connected load. The installation must be modified to correct these deficiencies and comply with the National Electrical Code. This can be achieved by installing a 225 amps main breaker in the 225 amps panel board, replacing the subfeed lugs with a properly sized feeder breaker and feeder, and ensuring that all conductors and overcurrent protection devices are properly sized for the connected load and voltage drop. A qualified electrical engineer or electrician should be consulted to ensure that the installation complies with all applicable requirements of the National Electrical Code and other relevant codes and standards. The National Electrical Code is updated every 3 years, so it is important to use the latest edition of the code. Many jurisdictions also have local electrical codes that may be more stringent than the National Electrical Code. It is important to comply with both the National Electrical Code and any applicable local electrical codes. The design of electrical installations should consider not only safety but also energy efficiency and sustainability. The use of energy-efficient lighting, appliances, and equipment can significantly reduce energy consumption and operating costs. The installation of renewable energy sources, such as solar panels, can further reduce reliance on fossil fuels. The electrical installation should be designed to be flexible and adaptable to future needs. This can be achieved by providing spare capacity in the panel boards and raceways. The installation should also be designed to be easily maintained and repaired. This can be achieved by using high-quality materials and components and by providing adequate access to all electrical equipment. Regular inspections and maintenance are essential to ensure the safe and reliable operation of the electrical installation. The inspection should be performed by a qualified electrical inspector. The maintenance should be performed by a qualified electrician. It is important to keep accurate records of all electrical work that is performed in the installation. These records should include the date of the work, the name of the electrician who performed the work, and a description of the work that was performed. These records can be useful for troubleshooting problems and for planning future maintenance and repairs. Electrical safety is paramount. All electrical work should be performed by qualified electricians who are trained in electrical safety procedures. Always de-energize electrical circuits before working on them. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. Be aware of the potential hazards of electricity and take precautions to avoid them. The National Electrical Code contains detailed requirements for electrical safety. These requirements are intended to protect people and property from the hazards of electricity. The proposed electrical installation does not comply with several key requirements of the National Electrical Code. These deficiencies must be corrected to ensure the safety and reliability of the installation. The installation of a 225 amps main breaker in the 225 amps panel board, the replacement of the subfeed lugs with a properly sized feeder breaker and feeder, and the proper sizing of all conductors and overcurrent protection devices are essential to bring the installation into compliance with the National Electrical Code. By addressing these issues, the electrical system can be made safe, reliable, and compliant with applicable codes and standards. Remember that proper electrical design and installation are crucial for the safety of people and property. Ignoring code requirements can lead to hazardous situations, including electrical shocks, fires, and equipment damage. Consulting with qualified professionals and adhering to established standards are essential steps in ensuring a safe and reliable electrical system. The information provided here is intended for general guidance only and does not constitute professional engineering advice. Always consult with a qualified electrical engineer or electrician for specific design and installation recommendations. By taking the necessary steps to correct the deficiencies in the proposed electrical installation, the electrical system can be brought into compliance with the National Electrical Code, ensuring a safe and reliable electrical supply for the building. The goal of electrical codes and standards is to protect people and property from the hazards of electricity. By following these codes and standards, we can create safer and more reliable electrical systems.